Thank you. Thank you. First of all, can you hear me well? Yep. That's cool. So I don't see a lot of people there, but I hope everyone survived last night and party. And just wondering if anyone went to bar yesterday. Cool. Anyone heading for today? Probably it's a good idea with such kind of weather, so you can consider this. Well, just a little bit about myself. My name is Daniil. I am a software engineer who was born in Kazakhstan many years ago. Maybe you hear about this country in the Central Asia. I'm a software engineer, currently living in the Netherlands for 3 years and working for Booking.com. I worked a lot with the distributed systems and inter-service communications. That is something I really like and want to explore more. And recently, I switched from C# and .NET to Java world. Does anyone work with C# here? Cool, you're lucky. And with Java? No one. That's really first time no one worked with Java in the audience. So that's interesting. I also used to give a few public talks in the past. That is something I really enjoy, but always nervous as the first time. Anyway, excited to be there, and it's going to be the great journey for all of us, I hope. And before we start, I want to point out that I'm not going to cover the monolithic versus microservices or how to split one into the set of services, as well as don't discuss the distributed transactions and sagas. Those are great topics and definitely deserve as a separate talk and also well covered already. And instead, I want to focus more on the way how can we share data between services by either utilizing the shared database or accessing data real time or probably asynchronously. And talk about the trade-offs. Software engineering always about the trade-offs after all. And let me introduce Alex. Alex is my imaginary friend, but I think you also know him because he's the backend engineer who did a lot of nice things in the past. He enjoyed being the software developer and work with the modern technologies. However, he was always dreamt about his own company. And one day, being a huge fan of homemade pizza, he decided, why don't create something to connect the ones who produce the pizza with the ones who can order it? And he created pizza as a service solution so everyone can enjoy it. And it turned out people like it a lot. And even more businesses wanted to onboard, not just pizza, sushi, whatever. That sounds cool because business is growing. However, that brings more concerns for Alex and his team. From one side, he has customers and business owners who want to see features shipped fast, who want to make money and finally have a fast system, have a good experience. And from another side, there are engineers who have to ensure all these requirements. They want to use the technologies they want to maintain the level of dependency. And from all the loud voices, there is something about the microservices. How do we get better with technologies? So we go read some books, maybe a few articles, definitely a couple of YouTube videos, and now we're getting experts. But jokes aside, microservices with us over the last decade, so that it's definitely something to consider when create the new design. And after hundreds of discussions, brainstorming sessions, and Zoom calls, Alex and team came up with a new design proposal. Instead of the monolith app, we have a number of well-designed services. Each serves specific needs. But I think you already found something suspicious there. Do you have any idea?
They are all using the same.
Exactly. There's a shared database in the middle. And who used the shared database in your project? No pressure? Cool. That's not only me. That's nice. If we go Google or refer to the books or simply ask ChatGPT, it appeared that shared database is the anti-pattern and we don't have to use it and avoid at any cost. But is it really that bad? Let's figure it out a bit. We have a lot of talks with Alex in the evenings and find a number of useful things. First of all, if it's supported, they are ACID transactions. If we're talking about, let's say, payment system, it might be crucial because we're talking about the data integrity, data consistency, and money we don't want to lose. Secondly, query enjoy data is way easier because we utilize as a database engine which is supposed to be doing that efficiently. And finally, we don't need further development efforts for that. We can just save some time and deliver more value for our customers. But talking about the drawbacks, most probably first going to be coupling. Imagine we have two services, users and delivery, which consume the same table. It might be shared fields, it might be specific fields. One day, delivery go with proposal. Instead of billing address, they want to split it into the 3 separate fields because it's just better for their internal implementation details. And after rollout, users may experience a problem because they're not ready yet. They still rely on the old schema. In the real world, we barely have any problems on production because we have some testing environments before, we have smoke tests, we have some process around it, maybe code reviews, but definitely something to coordinate between teams. And they're just 2 teams. Imagine you have 10, 12, etc. But we kind of can mitigate that risk even within the shared database. So let's introduce the private schemas, users for users and delivery for delivery, and access the special rules. So no one can access my data. Now we kind of isolate it on the same database level. And even more, we can expose the data to the out world by providing the public views. So if someone wants to request my data in the real read-only mode, they can do that. But we have to take into account that the more views they have, the more hell it's going to be. Because, again, view, it's not a physical representation. It makes a request of the tables. If you change table, you have to update view correspondingly. And if it's consumed by someone, you have to do it in a non-breaking way. And yeah, the more views they have, the more hell it's going to be. I think you kind of familiar with the case when you're afraid of deleting some part of code or some objects because it just works, don't touch it. Otherwise, might be a problem. The second point is the bottleneck. We have a European Cup next summer. Any football supporters here? Nice. Probably you are the target audience of Alex also. Delivery team, they expect more orders, so we want to scale out service correspondingly by adding more instances to handle the HTTP traffic, but this traffic ends up as a read-write operations on the database level. And finally, the system performance may get worse, and the specific service may experience problems like connection, timeouts, etc., because database also has its own limitations. The CPU, memory, network, they all define the bandwidth, and it's not indefinite. So we somehow have to scale the database correspondingly. Might be challenging, but if you have a cloud solution like DynamoDB, you can provide an auto-scale, or if you have a dedicated DBA team who manage cluster for you, it's not a problem. You just provide the quotas you need and consume the resources. So that might be mitigated. But again, it's challenging, and depending on the case. Also, we may experience some performance issues, especially long-running operations, depending on installation level, may block the tables, so we need to wait more, or concurrency issues, and the same services, different services consume same table, they kind of update simultaneously, and you can overwrite data, you need to solve it on the application level, these concurrency issues. And there is no such things like polyglot persistent. Payment team goes to Alex and asks to use the event sourcing, and they want to utilize event store DB because it's just better for their case, to create a snapshot, etc., etc., etc. Not much things we can do about it because we can maybe convince them using the existing engine, but eventually they're going to separate because it's just better for them. And just to wrap up this first part, shared database definitely has benefits like a transactions, querying, no development efforts. But on another side of the plate, there's a coupling, there's a bottleneck, performance issues, no polyglot persistence. So there are trade-offs we need to think about. And we thought and discussed with Alex and his tech leads and came up with a new design proposal. Instead of shared database, we utilize the database per service pattern right now. And now the question is, if data exists within the service boundaries, how can we access it across the services? Because we still need it. We go to Jira, take the first task from the backlog. We are lucky because there are some Figma mocks. It's pretty clear what do we need. And we want to show the menu item review card. If you take a close look, you can see that data comes from at least, 4 different places. We get user photo from user context. We got a review score from review service. We get the menu item from the menu. And finally, order from order context. So just to show this one card, we have to get data from 4 different sources. Okay, let's just move our communication onto the application level instead of database and make the service-to-service calls. Now, the review service, which is responsible for feature, can call the menu, users, orders, get all the data, provide the aggregations, and respond to the front end, to any other callers, whatever. And we can use the existing transport, like GraphQL, gRPC, REST, maybe you have another one. But we're introducing the network as well. And now we communicate over the network, we need to know about the services. We need to maintain the configuration complexity like service discovery, and we need to ensure the fault tolerance. What should I do if one of the requests is failed? And if they have some sequence of requests? Should I provide a partial response? Should I have a fallback? Should I just retry somehow? Well, everything on the application level, we have to manage it. And it gets even more complicated when you have the second service calling the same data providers. There should be room for improvement. And the very first idea in my mind was service mesh. Do you heard about service mesh? That's a simple idea. It's kind of infrastructure level before your service. If you're thinking about the implementation, it might be a sidecar in front of your pod, in front of your application container, which kind of gets the responsibility for handling traffic, for load balancing, for tracing, for logging, etc. But there is nothing about aggregations. So it's kind of complementary solution we could implement. It's actually nice to implement just to split responsibilities. But to get the aggregations, we can utilize the API composition. Instead of all services called the data providers, we have a single service in the middle, which is responsible for getting data, for providing aggregations. We can also encapsulate the high configuration complexity and encapsulate the unified fault tolerance experience here. And I'm pretty sure you already use it a lot. Does anyone has the API gateway in your systems? Maybe front-end applications who call the microservices, they have a single entry point. That is kind of common implementation of API composition. Maybe someone works with the graphical orchestrators. That's also quite useful thing. And I would like to have a few words regarding the Apollo Graphical Federation. I think it's worth check because it helps us to maintain the level of independency and still connect the services between each other. The idea is simple. Each service exposes the graphical API, and it's supposed to be a subgraph. And there is a router in the middle, which combines the subgraph into the supergraph from one side. And from another side, it handles the requests and smartly navigates to the right direction. So we touch only resolvers we need here. You may find it useful because, as I said before, it feels like we maintain services independently. If you need to onboard one, you just create a graphical API, expose one endpoint, go to router and onboard it, just like register one time. And we don't have to stitch the schema manually. It's the router responsibility to do it out of the box. And this solution quite well documented and have some examples from Apollo Federation. But there are some considerations. Obviously, graphical dependency. Maybe you don't have this, maybe you don't like this. That's totally fine. Also, if we want to change router behavior inside to make requests faster, I don't think we can do this. It's a kind of black box. At least I didn't find a way to trick it somehow. And it has this learning curve. The graph code itself, we need to know about it, we need to learn it, and we also need to be aware of the big picture about the supergraph, because if you open the schema, graphical schema, you can see some annotations. Feels weird, but when you know the entire picture, it's gonna be okay, it makes sense. Getting back to API composition, as we said, we introduced a single point in the middle to request data, to provide the unified fault tolerance experience, to hide the configuration complexity, but that also means we have the single point of failure. Now we need to ensure this composition in the middle is highly available, observable, scalable. Also, we introducing the latency due to networking, so we may expect more time for our requests to respond. And it's not clear how can we scale the services behind. If we put more traffic onto the composition level, should we scale the services correspondingly? Or should we somehow make it clear on the cache level, et cetera, et cetera? So there are concerns we need to take into account. And again, wrapping up this part, with the service-to-service call, we can embrace the communication onto the application level instead of database. With the API composition, we have a single aggregation point to hide the configuration complexity, to ensure the fault tolerance, but this point getting critical. We have a network latency, and it's hard to scale independently. And the last 2 points are really crucial for Alex and might be a nightmare because he knows there are some SLA between him and users. Some of the endpoint have to respond within the 200 milliseconds, so there should be something we can improve there. Okay, let's imagine we request data from single subdomain, and it already has everything. Let's bring the data to our subdomain instead. For example, we can utilize the integration events. Anytime menu item or users or order context changes, it just fires an event into the topic, and review service, or whoever interested, just subscribe on these events, gets the data, provide the aggregations, provide the translations, and put data in the store. Feels okay because we kind of moved this integration onto the background side asynchronously. We eliminate the networking. We don't have to call data in real time. And now we can scale data just inside the review service. We can also query them efficiently. But we have to take into account there is stale data here. Oh, it's weird, it doesn't work. Now it works. The stale data, we don't know when event is processed. It takes time for system to get consistent. And we don't know where something can happen. It can get wrong on the producer side, on the consumer side, maybe infrastructure struggling. It has to be observed, and we don't guarantee the data is consistent across the system services. Another finding by Alex that this setup looks good in terms of decoupling because services don't have direct dependencies. Now they kind of interact on the queue level. And it's probably correct, but there is a trap here. Imagine the menu team, they decided to have a unified event in single topic. Anytime something changed, they fire an event, it's just one topic. Whoever wants subscribe on it, consumes data updates, etc. But this event schema feels very close to the entity itself. And if you change anything inside the menu service, you probably have to update the event correspondingly and eventually have to update consumers. And now we're getting back to coupling, we're getting back to coordination. Probably instead of unified event data-oriented, we can have more business-specific events. For instance, menu item renamed, we just fire ID and name, or item promoted or deactivated. In that case, it's just item ID. Those fields barely will be changed, so it feels you can safely provide any updates on the menu item side and the menu service side. And the review and analytics service, they can subscribe only on ones which they're interested in. So if I'm interested in just in the item name, I subscribe on the menu item updates, renames, and I don't have to filter out messages later, like just consume what I need. But yeah, trade-off here is more complicated, more topics, more events. We have to deal with that. When I prepared this talk, I also thought about change data capture, and I want to ask if you heard about this change data capture thing. Cool, that's something also was unclear for me before. But the idea was also simple. We just make a system reactive on your database changes. When you have some, I don't know, changes in your transaction log for SQL database, you can just fire an event and notify outward. I heard about it in case of ETL or data warehouse data collecting, but why not use it for microservices? That's a good question. And for instance, there's a tool called Debezium, which built on top of Apache Kafka. I think it utilizes pretty same concept as we just exposed before. And if it can simplify the infrastructure, the management, why not? Something to consider. I have never used it in production, so not much to say, but definitely something I will put an eye later. And the event don't goes for free. We need to maintain the infrastructure. Also, we need to ensure the observability and error handling on the high level, because again, everything can go wrong on multiple places, and we have to know about that. There is no real-time data. It might be the biggest concern. If you have to run your business logic over the real-time data, that's probably not the solution for us. And you may need to backfill existing data. Imagine you have a new service. You have to bring data from different places, and there are already gigabytes of data somewhere. There should be a way to bring them, and we have to think about it. And it feels not easy to utilize even from the scratch if you don't have this infrastructure already onboarded. And I agree with Alex here, definitely. Maybe we can think about something more simple and useful. Let's just have a materialization job running with the configured delays or according to cron schedule, which will get data from data providers, provide the aggregations, put everything in the store, etc., etc. If you deploy your applications into Kubernetes, it might be a cron job. If you have a cloud solution, it might be serverless, like AWS Lambda, etc. But it can be just simple scheduled task in Java or background service in the .NET. And the main thing here from the data providers, you don't have to do a lot. They already exposed the service-to-service call API. And that's it. You don't have to fire events. You don't have to onboard it here. And the materialization job is going to be concerned on the specific service. In that case, it's review. So it feels easier to implement, and we don't have to deal with events in management infrastructure. Also, it's totally fine to combine approach. Imagine you have a number of records you have to transfer, and it's quite a lot of data. You don't want to do it like every hour, every half an hour. You can just have a bigger time frames, and in the background, utilize the async updates via events if you have this infrastructure onboarded later, just to make data more fresh. So the main point here, it's totally fine to combine approaches. And to wrap up, with the asynchronous communication, we eliminated the networking. We are able to scale independently because now it's a concern on the single service. And we just query data within the service boundaries because we have everything we need. But, yeah, trade-off, we have an infrastructure required here. We increase the overall system complexity because we need to onboard more services, observability, support some other things, and we deal with stale data. So might be not the case for us. Just to wrap up these patterns, we have some with these pros and cons. I strongly believe in your experience you also had the specific cases where you maybe implement something different. Would like to discuss if you want after. The big question, why this doesn't work? No. The question is how to choose the best pattern now, because, okay, we have some options, but a bit lost. And I agree again with Alex, so I also a bit lost. How to define this? Well, we built our system based on facts, and those facts came from different places. System requirements, business requirements, team limitations, timelines, etc. Let's just put everything on the table, all the characteristics, and now we have a use case. For instance, we need to provide the menu item report to see how it performs. And the business owner wants to do that. Just want to put some limitations, start date, end date, and see how it works. And the main request for here side, it should be in the real time, because even 1-2 hour delays might affect the picture. So the real time data should be in place. Also, he wants to see it ideally yesterday, so time to implement also a concern for us. But the team don't want to maintain a lot of complexity. It should be pretty simple. That's requirements from team. By the way, just example, might be different for your case. It's totally fine. Let's just do the simple exercise here. Put all the characteristics and compare options among each other. For real-time data, service-to-service call API composition is fine. We can go with that. But it's not the case for integration events and data materialization jobs. So now we can abandon last two options and proceed with the first two. Time to implement. I think service-to-service code should be faster because we already have this API. We don't have to introduce something new. For API composition, we at least need to onboard a new service. But for the system complexity, it feels like API composition should be better because it can be reused. It's extensible. For service-to-service code, it's going to be like a lot of requests around. After the discussion with the team, we decided that we still can deliver within the timeline. So let's sacrifice the time to implement and choose the second option, which is better for the future. And now the second use case. You can see that the data are pretty same services we need to consume, but now we need to provide the details for the application user. He wants to see the menu item reviews before to make an order. And yeah, it also affects the characteristics because it's a customer-face application. It should be kind of good in terms of latency, but you don't have to embrace real-time data. If he sees some like events lost before, it's not going to change the picture. Still have a lot of rates and doesn't change a lot. In terms of scalability, might be a case also because if we have more people to order, they can increase our peak loads. And team, again, don't want to manage infrastructure a lot and do the same exercise. In terms of latency, it's not a case for service-to-service code API composition. It might be more time because of the networking communications. But that's the thing for integration events and jobs, which we use for materialization. The same story about the scalability. So now we can abandon the first two options and choose between the last two. And since we don't need to use the infrastructure for events, data materialization feels the better solution for us. Now we have winner. And what we just did, first we collect the characteristic of the system. After that, we filter out the relevant ones for the specific use case, perform the trade-off analysis, and finally made a decision. And the key takeaways here is the context is important. It's not the same for different cases. It's not the same for different companies. If someone supposes it's a best practice, not necessarily it works for you. The characteristics drives the analysis for us, so we rely on them. And there are trade-offs. We can't just have the best solution which fits everything. We need to choose, sacrifice something. And now I want to say thank you, everyone, for participating, because now we have a challenge solved for Alex, and he's ready for the next big step. And I would be happy to answer your questions now or later. Feel free to catch up. That's it.
Any questions? Let me just ask one question in terms of your very first approach. When you were talking about how to approach different services, you suggested to add a composition layer, and all the requests are going to this composition level, and it becomes a bottleneck and causes some issues. However, why not to add, let's say, an adapter, a unified adapter, before each service? And this adapter could be developed by the team who needs it. So in this case, we could assure that the interface will be the same, and there won't be any problems in terms of disrupting the service, because the team who makes some changes in the business logic will also maintain the adapter, and it's not a big deal to maintain it.
Yeah, I got it. The question, just repeat, and correct me if I'm wrong. You're talking about, let's have the kind of interface, public interface in front of the service, which other services rely on, which hides all the implementation details behind.
Unified across all the services?
Unified across all the services.
Yes, at least on the architectural level. Yeah. And the team who needs it, maintain it.
Okay, that might be a solution, but I don't understand how can we kind of keep it consistent. But still, if you have some breaking changes on your side, inside, you still need to modify your interface. Probably you need to add additional, imagine you have a public contract, you add additional fields. You also have to update the interface, and you have to do it in the non-breaking way, so just putting more. And if you want to remove some fields, you need to duplicate it first. You need to ensure no one consumes it. After that, you can remove it. So I think that's kind of same problem as we had before. And with API composition, I believe it solves more the data aggregation problem. So instead of, if we have adapter, we still can call the services independently. Maybe we can somehow have this aggregation logic on this super level, like adapter level.
But it means that if you have breaking changes in any of the databases or in any of the microservices used, you would have to update this composition level, which means that if you have, let's say, 100 of microservices, it will be updating constantly. So you would have to merge, you would have mesh of PRs, etc., etc. However, when you have interfaces, you just update whatever interface adapters. You just update the adapter you need to update.
That's true. That's true. I think we will have this problem. But again, this API composition is more about solving the data aggregation problem. In terms of updating, in terms of like breaking changes, non-breaking changes, this thing about the GraphQL Apollo Federation, which I shared before, might be a thing because it's just single endpoint. You expose, you don't have like update your contract directly. You just make updates on your site. The router know about it, and you just publish the schema somewhere, and everyone can know about that. However, it's also have to be done in the non-breaking way, because you can't just delete the field and everyone else like request it. It's gonna fail eventually. So personally, I don't think that's possible to avoid that problem at all. At least I've never saw like a unified solution, maybe some kind of like dynamic generation, etc. But if we have clients, consumers who like consume our public contract, we have to make consistent change. We have to make it clear for them, and most probably is going to be next step. Few steps: update, field, deprecate, remove.
Any other questions? And thank you again.
Thank you also for joining.